Okay, guys, so in our next lesson here, we're going to be discussing about how we can classify quadrilaterals into one of these categories: parallelogram, rectangle, rhombus, or square. So basically what we have to do is we have to check for the congruency of the sides of the shape, right? So depending on if all four sides are equal or just the opposite sides are equal. And then we also have to check for the congruency of the diagonals, right? And in doing so, we're using basically a total of 6 distance formulas, right? So 4 are coming from all 4 of the sides, and 2 of them are coming from the 2 diagonals. And then depending on what the results are, we could fall into one of these 4 categories. So if we have opposite sides being congruent, so these are congruent and these are congruent, and then we have the diagonals are not congruent, then that would mean we're in a parallelogram situation, right? Because the parallelogram has these guys, has one of them being longer than the other, right? If, on the other hand, we have opposite sides being congruent and the diagonals are the same length, okay, then we must be a rectangle. Third possibility is we have all 4 sides being equal, but the diagonals are not equal. That would be a rhombus. And then finally, if we have all 4 sides being equal, and then the diagonals are also equal to each other, then that would be a square. All right, so let's see how to do this in practice. So the first thing that I would do is just draw the square out, and remember to label it in a circular fashion. So A, B, C, D. And then we could actually draw in also the diagonals, which would be AC and BD. So here's what we want to do. We want to basically find the distance of each side. So the first side is AB, then we have BC, then we have CD, and the last one will be AD, right? So these are the 4 sides of the quadrilateral, and then you have to do also the 2 diagonals. So the diagonals are AC and BD, okay? And for each one of these, we're basically going to be using the distance formula. So let me write the distance formula up here at the top. D squared is change in x squared plus change in y squared. So what I'm going to do is I'm just going to do the change in x and square it, the change in y and square it, add the results, and then square root at the end to get rid of the square on the left side. Okay, so first up is AB. So the change in x is -1. That has to get squared. And then the change in y is that it's going up by 2, and that also gets squared. So we have 1 squared is 1. 2 squared is 4, so we get 5. Don't forget the square root as your last step. Next up is BC. So for BC, change in x is that it goes down by 6, and the change in the y value is that it goes down by 3. Now, if you want to, you can actually ignore the negative signs if you're plugging this into the calculator. But if you do plug it in the calculator this way, you need to use parentheses around your negative numbers. Otherwise, you get a wrong answer. So anyway, here we get 36 plus 9, and that's 45. Don't forget the square root. Next, we have CD. So the change in x is 1. The change in y is -2. Okay, so we get 1 and 4, so that's 5 square root. And finally, we have AD. So for A, the change in x is that it goes down by 6. The change in the y value is it goes down by 3. So this equals 36 and 9, so 45 square root. And what we notice is that AB is equal to CD. We could say congruent. And then we have also that BC is congruent with AD. Right? So we have opposite sides are congruent. So if we look up at our chart from above, opposite sides being congruent, that puts us in one of these 2 possible categories. So now we have to look at the diagonals to see whether or not they're equal. Okay? So that we can limit ourselves to just one possible category. So next we'll look at AC. So as I go from A to C, the change in x is down by 7. The change in y is down by 1. So that equals 49 plus 1, which is 50, square root. And now we need to do BD. So the change in x is down 5. The change in y is also down 5. And so we get 25 and 25, which is 50 square root. And lo and behold, we have the diagonals are equal. Diagonals are congruent. And what that means is that since we were narrowed it down already to a parallelogram and a rectangle, the one with the diagonals being congruent is the rectangle. So together we would say that this is a rectangle. Okay? So now your turn to try number 2.